In this video, we'll take a look at the filter tool, which conceptually is very simple to understand. Now, the filter tool will take in a set of data and will evaluate each row of the dataset against a condition or multiple conditions that you stipulate in the filter tool's configuration options. If rows of data meet those conditions, they will then be evaluated to true, and the data will feed to the true anchor, which is denoted by the letter T. If the rows of data do not meet the conditions stipulated in the filter tool, they will be evaluated to false and will feed the F output anchor. The datasets that feed the T and the F streams respectively can then be used in subsequent parts of the workflow. Now, there are lots of different conditions we could write, but the key thing is to write Boolean expressions, i.e. conditions that result in either a true or false result for each row in order for the tool to work. So let's take a look at how we can use it with a few use cases. Firstly, I will drag an input tool onto the canvas and connect it to a sample dataset called restaurant, which has information on a list of individuals and how much they've spent at restaurants. I have also attached the dataset in the resources section if you'd like to connect to the same dataset yourself. So as you can see, we have 5 columns of data showing first name, last name, age and gender, as well as the dining out expenses for each individual. So if we add a browse tool to this dataset and observe the profile of the dining out expenses column, we can see the smallest value is 2.6 and the largest value is 998.76 with an average of just over 503. Now, these statistical observations are based on the entire dataset, so all 283 records are considered in this average calculation. But what if we wanted to conduct a slightly different piece of analysis? Let's say there was a data analyst who was responsible for looking at female expenses, and another analyst was responsible for the male expenses. Well, the filter tool gives us the ability to split this dataset into 2 streams based on the conditions we include in the tool. So we'll first delete the browse tool, and then we'll drag a filter tool onto the canvas so that the output anchor of the dataset is feeding into the input anchor of the filter tool. Now, in the configuration window, you will see 2 options. We can firstly create conditions using the basic filter, or we can input conditions based on the custom filter, which is more flexible. Now, with the basic filter, you're able to select a column for which you'd like to create a condition for. So using the example of splitting the dataset into male and female streams, let's base our first condition on the gender field. Next, we have a drop-down which allows us to select a comparison operator or function that can either be assessed as true or false. For example, if I were to select equals in this example and then enter the letter F for female in the final box, what we are essentially saying here is Alteryx should go through every row of data in the dataset and look in the gender column. If the gender equals F, then that row should be evaluated as true and should subsequently feed into the T stream of our filter output anchor. Now, you can add browse tools to both of these anchors simultaneously by selecting the Add All Browsers option, but we can also add a browse tool to the true or false anchor respectively if you wish. Now, when we run the workflow and then select the canvas to bring up the messages window, you can see that the input has pulled in 283 records, of which 139 records evaluated to true, meaning that 139 records were populated with the letter F in the gender column, and 144 evaluated to false. If we click on the browse tool off of the T anchor, you can see that our dataset now only contains the data relating to females, which have a minimum spend of 3.23 and a maximum spend of 998.76. The average is calculated at just under 520. The stream that's evaluated to false, on the other hand, is populated with M in the gender column, and this dataset has a minimum value of 2.6 and a maximum value of 998.52. The male average expenses come in lower than female expenses, with a value of 486.9. So already we can start to paint a picture as to the differences in spending of females and males with respect to this dataset. Now, so far we've covered a very simple example where we use the basic filter to compare the gender column to the letter F. If there's a match, it's true. If there's not a match, it's false. But let's now copy and paste our first workflow and create another filter condition, this time on numeric values. So if we change the basic filter field to be dining out expenses, which we know is a numeric field, you can see we're presented with a slightly different list of comparison operators. So we can create conditions using the equal to, not equal to, less than or equal to, greater than or equal to, is null and is not null. Now these comparison operators will come up throughout the course, and I will also include some additional material on what they each mean if you have never come across them before. But for the purposes of showing how the filter tool works, we'll use the greater than symbol, which is denoted by the right-angled bracket. Now in the third box, we can stipulate what we want the dining out expenses to be greater than in order for the rows in the dataset to evaluate to true. So if I put 800 as an example, what Alteryx will do is once again search through the dining out expenses column, and where the row's value is greater than 800, it will be flagged as true. And if it's not greater than 800, i.e. 800 or less, then it will be flagged as false and will feed the F stream of the filter output anchors. So when we run this workflow, you can see that the browse tool of the true stream now shows us a mixture of male and female genders, but all of the expenses are greater than 800, which you can see is the case based on the minimum value in the profile view. And if we select the false stream browse tool, the maximum value observed in this dataset is 792.18, which is clearly less than 800. Now so far, we have just observed how to write basic filter conditions to obtain true and false datasets. But let's now move on to create slightly more granular Boolean expressions. So we'll once again copy and paste the workflow, and in this third example, we're going to switch across and select the custom filter. And the first thing you will notice is that the basic filter has been translated into a custom filter, i.e. this is what you would have had to have written in the custom filter in order to replicate the basic filter. Now just on a side note, you will find the formula options in other configuration panes as well, which allows you to seek for specific formulas or functions that may be useful to you. And as you can see, they're categorized for easy navigation. So you can see conditional statement formulas as well as the different operators within Alteryx. You can also see many other options such as math functions, string functions, and so on. Now underneath this, you have a way of identifying existing columns and constants if you ever need a reminder as to what they are. But if you know your datasets well, then this will be used less frequently. Finally, you can assess recent expressions or saved expressions, which saves you from having to write the same expression out multiple times. And you also have the ability to save your expressions as per the final option. Now in this example, we're going to create a multi-conditional statement. So as well as checking to see whether the rows have dining expenses greater than 800, we also want to ensure that the true stream only brings through gender of female. So we can type an AND keyword, which simply means we want the first condition and the second condition to evaluate to true in order for the data to feed through to the true stream. Now after the AND keyword, we're going to start typing gender. And as you can see, we get a lot of predictive options that Alteryx brings to our attention, which can also help navigate formulas if you ever forget what they are. In this case, if I type GEN, you can see that Alteryx recognizes that we're wanting to search for the field gender, and when it appears we can press return accordingly. Now in a similar way to the basic filter, we can now state that we want the gender to equal F. So now only those rows of data that are greater than 800 in terms of dining expenses, and where the gender is F, will the data feed through to the T anchor. When I run this and then observe the top browse tool, we do indeed get a result back which contains all female data and only those records that are greater than 800. When we look at the second browse tool, you can see this dataset will comprise of all male data and female data where the dining expenses were less than or equal to 800. Now I could have changed the word AND for the word OR, and this would have brought back a slightly different result, as only one of the conditions would need to have evaluated to true in order for the row to be sent to the T stream. Okay, so hopefully this was useful to see how you could include multiple conditions to create some further granularity in your filtering criteria. But I just want to end on one other use case to showcase how functions can also be used to generate conditional statements. So I'll once again copy and paste the workflow and then select the filter tool. And this time in the configuration pane, we're going to write a condition that looks for first names that start with the letter A. If they do, we want them to evaluate to true. If they start with anything other than an A, we want them to evaluate to false. Now we don't want to have to scroll through the entire dataset and look for names starting with A and include them manually in our conditional statement. That's far too time consuming and not very sustainable if new records come into the dataset at a later point. So what we can do is utilize a string function to do some checking for us. So if I start by typing out start, you can see that Alteryx predicts that we're looking for a function known as starts with. Now you could have found this function by looking in the string functions list, but here you're able to see that the starts with function is expecting a couple of inputs. Firstly, it's asking us for the string that we are looking to observe. So in our case, we want this to be the first name field. Next, we have to provide it with a target, which simply means what you are looking to check that the string starts with. And thirdly, we can see that the function itself is defaulted to be case insensitive, i.e. the case insensitivity is set to true, and we will see a quick example as to how we can change this shortly. So as mentioned, the string we will use will be the first name field, and the target will be the letter A, which we will put in single quotes to represent a string value. Now seeing as we're not putting in the third argument to stipulate whether we want this function to be case sensitive, it will by default be case insensitive, meaning it will search for uppercase A's as well as lowercase a's in the first name field. When we run the workflow and look at the data that has fed the true stream, we can see that we get a result set that only has first names beginning with the letter A, and there are 26 in total. The rest of the dataset would have fed into the false stream. Now if I go back into the configuration window and put in a third argument to the case insensitivity parameter, I can do this by putting a 0, which can be translated to mean false, i.e. case insensitivity is now false, which means that the function is now case sensitive, and hence will look for lowercase a's at the start of the first name. When we run the workflow, we get 0 results coming back in our dataset, as they all begin with uppercase a's. Now once again, you can chain as many conditional statements as you'd like to create granular criteria, so we could add a second conditional statement which checks for dining expenses greater than 300. When we run this, our true stream reduces from 26 records down to 18 records, and we now have first names beginning with A which have expenses over 300, and this dataset can now be fed onto subsequent tools. So to summarise, if you want to split your data into 2 separate work streams, you're able to use the filter tool to achieve this. The filter tool can be based on a basic filter, or you can create custom filters which allows you to include multiple conditional statements using various functions to create Boolean expressions that either evaluate to true or false. Rows of data that meet the conditions feed to the true stream, whilst the remaining rows of data will feed to the false stream.